So good afternoon and thanks for your time. What I'm going to do is to onboard this Crosswork platform in AWS. So we are going to do the real implementation. It takes more than 40 minutes to come up, but the script will complete. And I'll tell you what will happen after that. Okay. So I have three screens to show you. The first one is this slide, and it may be overwhelming to see all the three screens. I'm just mixing up. So the blue screen is my PowerPoint. The white screen is the actual AWS. There's a black screen with the script. Okay, so easy for you to connect with what I am showing. So what we are going to do is to run the installation script. So we made this script in the BU, and it's part of the 5.0 offer. So you can download the script from CCO. And there's also a documentation that comes with it on installing this. So this is not a bespoke work. This is the official script that we are going to run. And then we can also see the options, which we don't do today. Like the customers may have different ways to implement, not just one way. So what other options are there and how you can do that? So that is the last part of my presentation. So before I go into the script, I'll just show you what we are going to do. So we are going to AWS, selecting a region, and in that region, we will first create the networking part. So basically the VPCs. So if you know AWS, I don't have to explain these terms. So that's the networking side. And then you can choose the availability zones where you want to bring up this installation. So that could be something closer to where you want to run your business. And then we create the subnets, the security part of it. We open up the ports that CNC needs to connect to the outside world. And then we start with the actual image installations. So the first image we install is the Crosswork cluster. So that is a Kubernetes cluster. You need a minimum of 3 VMs. It can be more. So this script will bring up that cluster and then wait for the others to come up. So you have CDG coming up as a separate installation, Crosswork Data Gateway, and then you have NSO coming in a different setup, and then you have 3 XRV devices, which incidentally is not part of CNC itself, but we want to bring it up to show that you can also bring up devices, not just Crosswork, because if you are doing a training or you are doing a POC, you need some devices. So the devices can also be taken from AWS and installed. But XRV is not really a part of the Crosswork installation. And then we have a Windows VM, which we are just bringing to show that you can have a more secure setup. Like you can have a jump server. If you don't want to open up your Crosswork cluster to outside world, you put them behind a jump server and just open up access to the Windows machine. So users who want to connect to Crosswork can come to the Windows machine and then do it locally within AWS. And the last part is probably where you can do a lot of customization. So that's what we call the API. So this API is where you can write all the APIs of Crosswork. So you want to run some specific app installation. You want to change the password. Once everything comes up, you want to reset password. Or you want to add devices to NSO, add devices to Crosswork Data Gateway. So all those things can be done through APIs. And the APIs can be added to the API section of the script. So that's one area where there will be a lot of customization. It will still do a lot of work, but if you want to customize, that's one area. So I'm going to show the entire script to you and everything will be clear. So this is what we are doing today. Yeah. SRPC is the XRV we are putting there. Yeah, good question. So let me jump to the script and run it, and then we come back to the slides, because it takes about 15 to 20 minutes for everything to complete. So if we start now, we should finish everything before the end of the session. So yeah. So what I have in AWS, I have a set of instances which I created yesterday. So you see here, these are all the images that have come up. So you have a naming convention that I just used to make it easy to understand. So you have NSO coming first, and then you have CDG, and then you have 3 Crosswork cluster VMs, so CW1, 2, and 3. So these are the 3 Crosswork VMs that came up. And then you have 3 XRV devices and a Windows machine. So this is the final output that you should be seeing. I stopped all the instances just because we don't want to pay money for one day, but this will be in running state when things come up. Okay, and we do this through this CloudFormation scripts. So CloudFormation, as you know, is the infrastructure as a code service that you are getting from AWS. So to onboard all the services of AWS, like they have more than 130 services today. So to create those services, you can write them as a script. The script can be in YAML or JSON format. So you can choose the format. And inside the script, you can put variables. You can have functions. You can have conditions. Just like a programming language, you script it. And when you run it, it just creates all the objects. So that's what CloudFormation does. So the BU has created the CloudFormation scripts to onboard all the objects that we have shown before. And we are running them in a sequence so that the objects will come up with just one click. Okay. So nothing has come up yet. So this is the yesterday's stack that I created. So if I get into the CloudFormation stack, what you see here is just one line. So don't look at this one. This is a different thing, which is not relevant to what we are doing. So this is the stack that we created. And inside that stack, if I look at the events, you would see that it started and then it first created the VPC stack. So all the networking part of the AWS is set up. And then there's something called workload stack, which created all the VMs, the CDG and CNC and NSO. Everything is inside the workload stack. So if you look at the timing, we started at 5:55 here, and we finished around 6:12. So that's about 17 minutes for the script to run. Now you can make a comparison if you have installed CNC, how much time you spent installing all these VMs, connecting them together. First of all, getting the servers, getting the licenses, talking to people, understanding the security. So everything was done in 17 minutes. It doesn't mean, like I said before, everything was up. This is the time at which the script finished, but the pods are still coming up. And based on what we measured, it takes about 45 minutes. So in 45 minutes, you can have a working CNC setup. Right? So that's what this script gives us. And before I go, I will just show you one more page. So this is the CNC 5.0 installation guide. This is actually in Cisco. So you have this documented here. So what we are showing today is already part of the documentation. The scripts are there and the procedure to run is also there. So as a customer or as CX or partner, you can refer to this for any customizations. Okay, so now let's go back to my third page, which is where the scripts are. So these are the scripts that we have got for installation. So they are all CloudFormation templates. And we are using an utility here called TaskCat. So TaskCat is basically a tool that simply runs these scripts. So you can run CloudFormation directly from AWS, but by using TaskCat, you can run it from SCLI. So the command to do that is TaskCat deploy run. So what it does is it takes the file taskcat.yaml. So this file is the starting point for TaskCat command. So here we have got some definitions like in which region you want to install. So that's US West 2. So that's the region where we want to deploy this particular setup. And you can change all these values. And then we have a starting template, which is called Crosswork entry point template. And that's somewhere here. So this will run the first CloudFormation template. Okay, I'll go through this later, but I'm just telling you the flow. The taskcat.yaml will send the request to the entry point template, and then everything starts from there. And you can also set up your key name. So this is very important. And this is the authentication that AWS expects from you. So if you send this request, it will first look at the key to know who is sending this request. And after the authentication, and if you have the right permissions, it will continue. Otherwise, it's going to stop right here. Okay. So let's run this. and see what happens. So I'm now running this script. So it starts with, you can see in the command window, it is doing some validation, and then it is going to trigger the request to AWS. Challenges in the sense, there are some concerns about security among customers, because Crosswork as a platform is talking to devices, right? And the devices are your uh, elements that you want to expose to the world. So there are some options to mitigate that. So I'll share that as part of the slides. But yes, there are some concerns on security. But every other aspect, if you look at it, this is better in terms of cost, in terms of time, in terms of people, skills. This is a better option. Yeah. Okay. If you are using it for a very long time, yes. Yeah, you can deploy it for 1 week. This is way cheaper. Yeah, no comparisons. Yeah, I'll show you the cost part at the end. Yeah. So I've just run the script. Okay. So what happens now is, if I go back to AWS, you can see that the second script should have come. Let me see. No, I just got disconnected. So let me open up another session. Okay, so let's go to the cloud formation page. And I also have the EC2. We don't need this. And the VPC maybe. Yeah, so in the cloud formation page, if I go to the stacks, you can see here a new stack is coming up. So I named this as current, just because I didn't want to invent a new name. So the previous one was what we ran yesterday, and the one we are starting now is called TCAT current. Okay, so that's coming up, and if I get into that stack, you will see that it has got one line, but this is a nested stack. So when I click view nested, it shows me all the child stacks that are getting installed. So in the very first stack, in the TCAT current, it simply says a request is sent to VPC stack, and that is completed. So the VPC part has been done, and the workload stack is ongoing. So if I get into the VPC stack, you can see what was done there. So basically it created all these objects as part of the script. So you can see a lot of networking constructs, the subnets. So these are all part of the script, and they all get executed and completed. And then in the workload stack, it now starts installing all the VMs that you need. So in the beginning, it starts doing a security group to set all the security rules, and then it starts SSM, which is the Windows machine. Then it starts the CNC stack, it starts the XRV, and then you have the, no, that's all. So CDG and NSO will come up later. So they will continue and finish. So as it runs, I'll come back and show you the progress. But this is all you need to do. TaskCat build run using the script, and the entire CNC setup comes up. Okay. So back to my PowerPoint. What we are doing here is to just give you the terminology first. Crosswork infra is the 3 server setup we are doing. So we are not installing applications yet. We are not installing active topology or health insights. We are installing the basic platform, the 3 node Kubernetes cluster. So the 3 VMs that are coming up are giving you the Kubernetes platform. And Data Gateway is a separate VM that gives you the ability to collect data from the network, which will be leveraged by the Crosswork applications. Then you have NSO, which is the provisioning part of the solution. So that comes separately. The Windows machine is for the jump server, It's an optional thing, but we have included it in the script. Then 3 XR devices, which can be used as SRPCE, but it's an option you can leave out if you want to save some compute. Okay. Then in AWS, we have created VPC, and then these are the terms that you may know. These are all the gateways that AWS offers to connect to different parts of AWS as well as outside. So IGW is the internet gateway. So if you want to connect the setup to internet, then you need to create an IGW. Then VGW and CGW, the VPN gateway and customer gateway, these are required if you are splitting this between on-prem and the AWS. Let's say you are installing some of these components in AWS and the rest are in your local on-prem. You need to have a VGW on AWS side. You need to have a CGW on the customer side. So those two devices create a tunnel, IPsec tunnel, through which the communication happens. You still need them. Yeah. You still need them. You still need to configure them so that they can communicate. So that's the security you get through the public internet. But if you want to eliminate that, like this could be one of the challenges you can look at. If you don't want to do that public internet connectivity, there's an offer from AWS called Direct Connect. So Direct Connect uses a partner in your location, and the entire communication between AWS and your site happens through the partner, like Equinix, and that's a non-public internet, much safer way to connect, but more expensive option, right? So these are the two ways to connect an on-prem setup with AWS. So VGW and CGW are for that kind of use case. Today we are not deploying them because we are running everything in AWS. So if you are doing a use case where you want to set it up in AWS, you want to destroy it, you don't need that VGW and CGW. And TGW is a transit gateway. It's another service from AWS. So let's say you are, for whatever reason, you want to deploy the components in 2 different VPCs. Like maybe there are 2 different owners within the company. So some people own the device, some people own the orchestration software, and they want to deploy it in 2 different VPCs. To connect the VPCs, you need a TGW, a transit gateway. So that's another option you look at. And then EC2, AMI, these things you know. EC2 is the compute part. AMI is the Amazon machine image. And we have machine images for CNC, for Crosswork Infra. We have images for Data Gateway. We have images for XRV. We have images for Windows Machine. So you can directly take them from AWS Marketplace and install them. So there's no need to get a VM or OVA from Cisco. They're all there. Yeah, that's the part we don't have yet. So the NSO AMI, we have built ourselves, and we have posted it as a private AMI. So there is work going on with NSO team to also publish NSO as a public image, but it's not there yet. Everything else is there. NSO, we are building it ourselves and using it. Yeah. And so this is what we will have at the end. So one VPC today, and all the components are there. Okay. And this we have seen, and this is how it is going to look like at the end. So what you see in each box is a stack. So a script creates that stack, and then there are dependencies as shown by the arrows. So each stack could have a dependent. So the creation happens in that sequence, and deletion also happens in the same sequence. And this is what we can do in CNC 5.0. You can have multi availability zone or single AZ. So you can, in the TaskCat, you can choose how many availability zones you want to use. You don't want to put all the images in one zone, then you can split it. Then the deployment CloudFormation templates are supported by the BU. Okay, so you can take it from CCO and use. And we are also supporting load balancers and Route 53. So Route 53 is the DNS service of AWS. So if you want to configure DNS, you can do it through the scripts. Okay. And this is an important thing to note. Right now, CNC 5.0, we are only supporting CNC Essential. That means we are supporting apps for active topology and optimization engine. In CNC 6.0, we will also support the Advantage. So that's all the other apps. Okay, that's coming at end of the year. And NSO and PCE can have HA, which is a good feature. And these are the three options you can have: single, multi VPC, or a hybrid environment. So in the single VPC, all components are in the same VPC. You don't need any of those transit gateways, VPN gateways, or customer gateways. We have tested it, and we are supporting it, and this is what we are doing today. The multi VPC we have not tested, but there is nothing that stops from getting this done because it's still inside AWS. It's just two different VPCs, so we must add a transit gateway to connect them, right? So that's the only extra part. The third part we have tested is between an on-prem and AWS. So some of the customers may have this kind of scenario, like their devices are already on-prem, but they want to use CNC to do the apps on top of those devices. What we have tried is with our dCloud, we have got different combinations, like we have installed Crosswork Infra in AWS, CDG in AWS, but NSO and devices are inside Cisco network. So we use the both VPN gateway and customer gateway, and then we connected them over the tunnel. So this is the second option we were talking about. When you have two VPCs, you install the transit gateway and connect them. So that's a pure AWS feature. And this is the third option where you have two VPCs and external on-prem domain. So you have a TGW here, and in that tunnel you have the VGW and CGW. Okay, so that makes the full complex setup of connecting on-prem with AWS setup. So these are all some details of what we have in the scripts. Most of that we have seen, like in AWS, we are creating VPC, security groups, then the IAM part of it. And then CNC, in the script, we are first defining the cluster instance, the basic VM, and then we define the interfaces that that instance needs. The common launch template, so this is where the IP addresses are set and all the initialization is done. Then the DNS setup through Route 53 and network load balancer. So these are the 5 operations we are doing in the current setup today. And the same for CDG, very similar. Then for NSO, we are creating the instance and defining the interface. A Windows machine is a very simple jump server, so we just create it. Then the XR devices, we create the instance, create the interface, and we run a day 0 config on that. And then the API server does all the post-installation tasks, like setting passwords, changing passwords, or adding the devices to NSO. I can show you that script later because that could be of interest if you are customizing that script. You can. It's an extra work you have to do. But if you want to do it as a script because you want to reproduce that many times, this is the place to do. Yeah. Yeah, it is actually the network load balancer service of AWS. So that decides the logic. So when you create the load balancer, you define the rule, whether you are doing round robin or you look at. Correct, correct. Yeah. So that's a feature in 5.0. Yeah. So let's go back and see what is done. So in the stacks, I'm going to see if it is done. It is still in progress. So right now it is it's working on this one, which is the API stack. So you can see that we have already done the workload stack for SSM, the Windows machine. We have done the CNC stack. We have done the XRV. We have done the NSO. We have done CDG, and now the API is running. So it will complete in a few minutes. And in the EC2 dashboard, if you look at it, you have all the instances running. So we have now 10 instances. So I'm going to search for a different name. Name contains, because we used current. So you can see all the VMs have come up. You got a CDG first, Crosswork 3, 2, 1, XRV 1, 2, 3, Windows, NSO. So everything is set up and connected together. You can start using it after about 45 minutes. The whole setup is ready in 45 minutes. Once it says running, it doesn't mean it's ready to use. The running part of AWS is done, but inside the pods are coming up. They are getting tested. So that takes about 45 minutes. Okay. So CloudFormation, you can look at the individual steps. Like there are a lot of details in what is being done. So if I, for example, go into CNC stack, you can see what it did. So basically, it created the 3 instances. It created a role, ECE role, placement groups. So a lot of work has been done, which manually doing is not a difficult thing, but takes a lot of time. Yeah, and you need the skills to do it. So let me go into the script and show you what exactly we need to do to run this, because your environment could be different, right? It's not exactly what I am doing. So where do you change? So the only place to change is this file, the TaskCat.yaml file. So you can see here a lot of parameters. So these parameters are all customizable. So I have, for example, here the Windows image name, the AMI name. This could be different for you. Same way the XRV image, these are the public images. You may like to use a modified image, so you can change those image names. So these are the names of the AWS images. Then you can change some IP addresses if you like to change. You can change the default password for Crosswork. You can change all the parameters here, and TaskCat will take them and apply. So here I'm saying availability zones 2. So we are trying to use 2 AZs. If you want to use more availability zones, you can change those numbers. So it's very easy to customize. Okay, and inside the scripts, I'll also show you what is there. So if I look at, for example, the entry point template, so there are a few important sections that you need to know if you are doing debugging. So in the top you have a metadata, which is like a definition section. We don't really worry about metadata, but there is a section called parameters. So each CloudFormation template has its own set of parameters, and these parameters are used inside the template. So these values are what is important for the template to run. So if I go down, there is a section called conditions. So in the conditions section, you can define some rules, like when a particular action should happen. It's like any programming language. So you can define here conditions like a condition name, and then there is a condition. But the most important section is this resources section. So these are the resources of AWS that you are creating. Okay. So first we create, this is in case of entry point, we are creating a stack and we are pointing it to a particular YAML file. Here it is called AWS VPC template, and that's here, AWS VPC template. So it's just like a chain that you run, basically a subroutine calling a subroutine. So we start with one stack, that stack calls the second stack, and then you can continue like that. But all these are done already by the BU, so you can straight away take it and deploy. But if you want to debug, if you want to understand what's going on, you can look at it, right? Region you change, key name basically identifies me to AWS, so that you have to create a key and put your key name there. I didn't change anything else. So from the other person who was running, but you may like to change some IP addresses if you like to have your own IP subnets. If the images are different, you change the image ID. I think pretty much that's all. Yeah. And in the API template, which I was mentioning before, here we are running some Lambda functions. Lambda, as you know, is a serverless code that AWS supports. So you can write any Python API call that will run on the machine. So here, for example, I have a code here, update default password. So this basically changes the default password in all the VMs. Okay, and these are Crosswork API calls, and you can add more things like here. So it's up to you to decide what you want to do after the VMs come up. You can also do that manually, as you said, but if you want it to be part of one flow, this is the place to do. And the stack is going to run this after the VM comes up. Okay, so we'll see again what happened. So it looks like it's completed, right? So now we have this TCAT current, create complete status, and we'll see how much time it took in today's running. So in the events, we started at 1:17 and we finished at 1:34. So it's about 17 minutes to complete. Yeah, it may take another 40 minutes to be fully ready, and you can start using it. Okay. So this is a estimate I made just for discussion. It may change depending on who you are, what type of agreements you have with AWS. So for a setup like this, where you have 5 instance CNC cluster, we use 3, but here it's 5. Then 2 CDG and 1 NSO instance. It takes about $4,000 per month. This is AWS. So there is a AWS calculator that you can use. You can get into the calculator, give your inputs, like how many servers you want, and what is the configuration you want, right? And then it gives you the price. Okay. And you can compare this with the cost you would typically incur if you are doing this on-prem, like you are getting 8-9 servers, the licenses for that, and then you are going to spend time installing them, testing them, so it's a people plus time plus skill. So AWS is solving those problems for us, and you also have the option to combine on-prem with AWS. So if you don't want to run everything there, you can run some part of it in AWS, but then you have to invest in the VGW and CGW. Yeah. So that's pretty much what I have to share with you. Is there anything else you want to discuss? No, you can specify in which zone you want to bring up a particular VM. Let's say you have 3 VMs. When you specify one availability zone, all the 3 VMs come in the same place. But you want to create some more redundancy. So you can say 3 availability zones, and then you give the zone name. And then, yeah. So, yeah, yeah. Availability zone is just a way to get redundancy within the same region, because they will be in different data centers. Yeah, correct, correct. Yep. So that's the idea. So it doesn't go across VPCs. It's still one VPC, but it's not one AZ. Yeah. The other part you can look at it is this VPC view. So in the VPC view, you can look at all the VPCs that are created. So the one we created now is this TCAT current. So if you look at it, it pretty much created all the subnets. You see here the route tables. So all the security part is done as part of the script. Okay, so you can't just go in in any way. So only the ports and IP addresses that we allow them to come in are open for people. Yeah. So there it is not like every device is open to the public. What they do is that CGW, that customer gateway, is the only device that is open to the outside world. All your devices are behind that device and they are not open. So that's the first thing. And the CGW configuration is generated in AWS, so you don't need to experiment. So I can show you that part. So let me quickly go to another data center. Sorry. No, he's asking about the opening the devices to AWS, right? I mean, so this is a setup we have built between Cisco dCloud, which is like a private, and then AWS. So what we have done here is we have configured the VPN between a customer gateway and this virtual private gateway. So this customer gateway is a device in front of the customer network, and this is the only device that is exposed to internet. None of the devices behind is exposed. Okay, so what you can do here is you can go here and select the site-to-site VPN, and there is a VPN here, and it is connected to, it's down now because we have turned off the dCloud setup, but there is a customer gateway connected to the virtual private gateway. So this is the only device that you are exposing, and you can generate the config for that. So if I go to the VPN connections, and here you have the download configuration, and then AWS is asking what is the customer gateway you are using. You see here the manufacturer of the customer gateway device. So you can choose the device that you are going to use as customer gateway. So let's say we are using a Cisco device. Then it gives you an option of all the Cisco devices you can use. So let's say I'm using ASR 1000. Then it actually gives me the full configuration. I can download this and I can apply it on the device. Okay, so that part is fairly good. Like you are not exposing 2000 devices to the internet. And this is all managed from AWS. But if you want to eliminate that, like you are worried about going through public internet, the other option, like I said, is the direct connect. So direct connect, you don't need to come through internet at all. Yeah. Yep. Yep. Yeah. So there's a NAT process that happens. Yeah. So there is a IPsec tunnel between the VGW and CGW. So they create the pipe for the tunnel for you, and then CNC devices or CNC applications can go through that tunnel to connect to your devices. Yes, correct. Yep. So I'm pretty much done. So any other points you would like to discuss?